I have had so many people asking me about this specifically. You know, what genetic testing have we done so far for Marcelly? Do you have genetic test results? So today I want to take some time to talk about that process, what we know, what we don't know, and what steps we are doing moving forward. So for those of you who are new here, prior to being a stay-at-home mom, I actually worked as a developmental pediatric physical therapist for about 4 years. So with my extensive experience in early intervention services, I knew from the get-go when we got pregnant with Marcelly that I wanted to do all the testing that we could from a genetic standpoint, so that we could provide her with the best care possible and have as much information as possible. And this was before we even knew that she had anything abnormal going on. So the very first test we did early in my first trimester, we did, I think it was the maternal 21 and the AFP test. Both of those came back totally normal. But when I went in for my 20-week anatomy scan and doctors started expressing concerns about her brain and other areas, we went ahead and decided to do an amniocentesis. We could have chosen not to do that, but like I said, we wanted to have as much information as possible because we wanted to know what we could prepare for in terms of her care. The initial line of defense in genetic testing when you do an amniocentesis, it's two tests. It's a karyotype and a microarray test. A karyotype test essentially looks at the size, shape, and number of chromosomes. And then the microarray test is an even more specific analysis of chromosomes. And both of those came back normal. Now again, a lot of people choose to stop there, which is totally fine. But we knew that because Marcelly has abnormalities in multiple systems of her body that are very complex, we knew that the likelihood of her having some sort of genetic component to this is very high. And that's why we chose to do what is called whole exome sequencing. So at the risk of boring all of you, we'll take a trip back to biology for a second. A single person's entire data book of DNA contains up to 25,000 genes, with a gene basically just being information to construct a specific protein. Each gene contains a variety of what are called introns and exons. And exons are essentially the portion of the gene that then become expressed into whatever specific protein they're coded for. The accumulation of all of our exons is called the exome and contributes to about 1% of our entire DNA sequence. So whole exome sequencing is looking at the entire exome, which would be like looking at 10,000 pages of a textbook. Sometimes we have disruptions or alterations in this genetic material that is not picked up on other genetic tests and screenings. There are a couple of different ways that you can go about doing whole exome sequencing. Now, because we had already had an amniocentesis done, the lab that did our karyotype and microarray sent off that sample that we already had to a different lab to do the whole exome sequencing. This was really nice, and I'm glad we went ahead and had the amnio done and that we're doing all of this before she's born because, you know, we already had that sample ready to go and they just sent it off, so I didn't have to do any additional blood work or an additional amnio, and it will prevent us from having to do, you know, additional blood work when she's born. And to get the most comprehensive look, Josh and I will also be sending off samples of our saliva in the mail, and I will do a video, like a vlog on that. So what they're gonna do is they're gonna take my DNA and Josh's DNA and Marcelly's DNA, and they're gonna look really, really closely at all of those exons, that exome. And the best explanation that I've found of this is that it's kind of like looking for typos in a book. Now, whole exome sequencing has what we call a positive diagnostic rate of about 20 to 40%, with higher rates resulting when you have both parents contributing like Josh and I are doing. So we could get results back that indicate she has a specific genetic abnormality or mutation to contribute to all of her medical issues. But there's also a chance that we could get inconclusive results. Many of us have genetic mutations that don't necessarily contribute to any kind of health problem. And there are also many, many genetic mutations that have not been identified yet. but there are hundreds of new rare genetic disorders that are identified every single year. So there's a chance that even if we don't get answers now, we could in the future. The test will also tell us specific health conditions that Josh and I may be at risk for later on down the line, or the likelihood that this genetic mutation could occur again. So much information.